Okay, factorising linear functions. This is about removing as much as we can from an expression as a common factor. So we're looking for the highest common factor, the HCF, of whatever terms have been given to us and putting them out front. If we can't remove something from one of the terms, we've got two choices. There is a possibility we could leave that term out and factorise the rest. It's a bit of a weird one. They wouldn't normally ask you to do that. Or we could say that the whole thing can't factorise. So let's just have a look at some really basic ones first of all. Really basic here. What's the highest common factor of these two terms? So what we're asking is, what can we multiply by something to give 3x and 6? So we've got 3 times x and 3 times 2, so 3 is our highest common factor. So it goes in the front. Then we ask ourselves, what does 3 multiply by to give 3x? Yep, x is pretty easy. And 3 to get 6? 2. Done. So that's fully factorised. I've taken the highest number out of both terms up there to get it to be factorised. So, what if it's not quite so simple? So I want the highest thing that can come out of 6x and 9. So I look at the numbers to start off with. What is the highest number that 6 and 9 occur in its times table? So the 2 times table, no. The 3 times table, yes. The 6 times table, no. 9 times table, no. So it is the 3 times table. 3 is the highest common factor between 6 and 9. All right? So we get rid of the 3 out of these two. But we've also got x's up here. So we've got to think about how many x's can we take out? This says basically you've got 2 x's here being multiplied together. This one, you've got 1x, so the highest amount you can take out is 1x. So we're going to take 3 and x out and leave ourselves here with 3 times what is 6? 2. X times what is x squared? Remember we said we had 2 x's. Out of this one, 3 times what gives 9? 3. And we've taken the x out. It's gone. All right? So this is fully factorised. Now I could have just taken the number out. And that would have been factorised, but not factorised well. We don't call that factorised because it's only partially done. We didn't take the x out. So we need to make sure it's the most we can take out of something. We also need to watch the sign, all right? Make sure that the sign is being kept consistent across the problem. So we could have 3 brackets. Right? So what we're looking for here is the highest common factor of 3 things, 8, 2, and 4. So what is the highest number that can be multiplied by something to give 4, 2, and 8? It's not 8, because you can't multiply 8 by something to give 2, right? So it's got to be on the lower side of all 3 of these. Yes, it's 2. Okay, so we've taken 2 out. Now we're looking at the letters in alphabetical order. We've got 2 x's, 1x, and 1x. So the most we can take out of all of them is an x. We've got 1y, 1y, and 2y's. So we can take a y out. All right, what is left? So over there to multiply this, to get that, we've got to go 2 times 2 and x times x to get the x squared. The y is gone, so we don't write anything in there. This one, we've taken everything. We've taken the 2, the x, and the y, but we can't leave it with nothing. So what multiplies by 2xy to give 2xy? Yeah, 1. All right? Not 0. 0 would mean it all vanishes. We're multiplying by 1. And this one, what do we multiply by? Minus is the sign for y. The x came out. All right? So these aren't too bad. Have a go at them.